All right, so you said y-intercept of -2, right?
Yeah.
Then from there, where are you going to go?
Up 3 over 1.
When we say over, which direction?
Right.
Okay, so up 3 to the right 1, up 3 to the right 1. Could I go down 3, left 1?
Yeah.
Okay, so that's going to be our line, right? Okay, now we have to decide based on that symbol right there whether we use a solid line or a dotted one.
Solid.
Why?
Because it's the line under it.
Okay, so these two symbols require us to use a solid line, right?
Yeah.
And the reasoning for that, that's all right. The reasoning for that is because the solid line refers to equality, meaning that points on that line actually give me true statements when I plug them into the inequality, when I plug them into the y and the x up here in the sentence or statement. Okay, so now and at the end Wednesday, we talked about this, okay? We can only read this as greater than, which is going to then imply to me that I'm going to shade on top of the line if the y comes first. Does that make sense? Okay, so we read that y is greater than, and because the y came first, we say, well, greater than means on top. So we're going to shade on top of that line. Okay? Now, if you have trouble deciding on top of the line, what I like to do is I like to go to the y-axis. We draw our stick figure. Okay? And we're going to drop that stick figure. And we're going to drop them and see where they hit the line. They stop right there, right? Now, he's going to be on top of the line. When they hit the line, their body then stays on the top side of it. Does that make sense? Is that all right, everybody? Okay. So that's why I'm going to shade everything up here.
Oh, man, I shaded the wrong side. I was going to take a little arrow and put it where it should be.
Okay. Now, the reason I talk about that is because if I go 3x minus 2 is less than or equal to y. Okay, 3x minus 2 is less than or equal to y. That is the exact same statement as what that is saying. It's just reversed order, right? Is the inequality sign still, and if it's an arrow, okay, oh, actually I've got that. Actually, I messed it up. If I do, so this inequality symbol should be that way, okay? If I read the first one, y is greater than or equal to 3x minus 2, if the inequality sign is like the tip of an arrow, it's pointing to the 3x minus 2 stuff, right? If over here, if the inequality symbol is an arrow, is it still pointing to 3x minus 2? Yeah. So are these two things the same? Yeah. Okay. But if I read this, how do I read that symbol right there? Less than. Okay. So when I see less than, you might think shade below, right? So the idea of greater than meaning above and less than meaning below, that is only going to work if y is coming first. Does that make sense? Otherwise, you have to do a test point. Okay. The next series of examples is going to show you how to use a test point. Okay. Lindsay.
So it's like I think you said, it has to be y equals less than shaded below.
Yep.
And then if it's not y equals, then you have to do what?
That's what I'm going to show you with the next two examples. Okay. Now remember what the shading means, and this is going to kind of introduce us to the next two examples. The shading means that any point that is shaded, okay, and I'm going to choose a real nice one here, 0, 0. Would you guys agree that 0, 0 right there is in the yellow shaded region?
Yeah.
What that means is I should be able to plug 0, 0 in for that y right there and that x right there. So we get 0 greater than or equal to 3 times 0 minus 2. 0 is greater than or equal to negative 2. Is that true?
Oh, greater than that.
Yes. 0 is bigger than any negative number, right?
Yes.
So what is happening here is that a point out of the shaded region gave me a true statement. any point out of that yellow shaded region will give me a true statement like that. Okay, it won't give me 0 is greater than -2. It'll give me a number on the left that is bigger than the number on the right. Does that make sense? Okay, so there's an infinite number of solutions here. So we're going to use that logic, that principle, to help us grasp the next couple. Okay, using the on top of and below aspect to shade, I think, is only a good practice if your equation, or your inequality in this case, is in mx plus b form, which is what we got here, right? Slope-intercept form. So let's do the next two. Travis, you have a question?
No, I was going to tell you that it's raining. You hear that? It's raining. No, it's not. I hear it not later. That's the fan off in the hole.
Absolutely not raining.
What is that noise?
All right, so 2x minus 3y is less than 6. 2x minus 3y is less than 6. You could do one of two things. You can leave it this way, which I'm going to hope you do, okay? Or you could convert this into y equals mx plus b form, okay? The only thing with y equals mx plus b, and it would not occur in these two situations, is like, say that number was a 7. When you solve for y, you're going to divide everything by 3, right? -3 eventually. You would have 7 divided by 3, which is going to be your y-intercept, which is a really hard number to plot, right? Okay? So in that instance, changing this into y equals mx plus b form is not a good choice. Okay? Whenever they give you standard form and they ask you to graph it, use the technique that we're going to talk about right here. And we've already demonstrated that we can do this. It's just kind of jogging our memory of it. Bless you. Remember that in order to graph this, okay, all lines have x-intercepts and y-intercepts, unless they're vertical or non-vertical, or vertical or horizontal, okay? So this, if I say x is 0, can you tell me what the y value would be if x was 0? If x was 0, would you guys agree that term goes away? And then how do I solve? So this is essentially -3y equals 6. Remember, we're graphing, we're treating them like equations. What would y be there? -2. Just divide by -3, divide by -3, right? Does that make sense?
What was that?
Okay. So that was when x was 0. Let's do this when y is 0. If y is 0, this goes 3 times 0, which is just 0, right? So I'm left with 2x is equal to 6. What's x going to be? 3. How many points do you need to draw a line? 2. 0, -2 is one of them. 3, 0 is the other. Okay? Now from there, you can maybe recognize your slope is up 2 to the right 3. So I'm going to actually use that to get another point there. Down to left 3. Down to left 3. Okay? But that point right there and that point right there are enough to create a line, right?
Yeah.
Okay, now look at your inequality symbol. Is it a solid line or a dotted line? It's a dotted line. Okay, so we'll connect these with a dotted line, which is going to tell me that none of these points on that line actually give me a true statement when I plug back into this. Any point on that line, when I plug back in, will give me 6 is less than 6. Is that true? Is 6 less than 6? No. So that's why we make it a dotted line, because that's not true. Okay. So now I have to decide where to shade. Okay. And because y is not on the left-hand side, isolated all by itself, you can't use the above and below idea. Okay. What you need to do is you need to choose a point that you can substitute in for x and y. What is the number one easiest point to ever substitute? 0, 0. Okay? 1, 1 is okay. But 0, 0 is even easier because of the multiplicative properties of 0. 0 times anything is what? 0. Okay? 1 times anything is that anything, right? So even though, so you could try 1, 1, it would work. Okay? But I'm going to try 0. Okay? 0, 0. I'm going to plug 0, 0 in for x and for y. If I plug 0 in right there, and plug 0 in right there, does everything on the left-hand side go away? And it leaves you with 0 on the left-hand side and 6 on the right-hand side, right? Is that a true or false statement? That's true. 0 is less than 6, right? So if you get a true statement, you are going, that means that's a solution. That means that must have came from the shaded side. Does that make sense? So 0, 0 comes from the shaded side. So then all the points that are on the same side as 0, 0 should be shaded as well. So I'm going to shade all that stuff there. Huh? No, the points on the line are actually going to give me a false statement. And they choose a point that's on that line. So, like the easiest, so maybe it would be, I don't know, 6, 2 is on there. If I plug 6 in for X, that gives you 12, right? 2 in for there would give me 6, right? So 12 minus 6, what's 12 minus 6? 6. So I'd have the phrase 6 is less than 6. And that's false, right? So that's why it's a dotted line. It's showing that anything you pick off of that dotted line actually gives a false statement up here. Okay? Now, if you wanted, so we shaded here. And now think about this. If I would have read this, 2x minus 3y is less than 6, and I would have just thought less than means below, I would have shaded in the wrong spot, right? That make sense? So when x's and y's are on the same side as one another, this is kind of the approach that you want to use. Now, if you were to use 1, 1, plug 1 in there, what do you get? 2. Plug 1 in there, what do you get? 3. What's 2 minus 3? Negative 1. Is negative 1 less than 6? Yeah, right? So we would have shaded that point, which we did, okay? But my hopes are that you see that plugging 0, 0 in and getting those two things to go to 0, that arithmetic is much quicker and easier than letting them both be x be 1, y be 1. Doesn't matter, but I like to choose 0, 0 if I can. Does that make sense? You guys take a minute and see if using the same approach, you can graph this one. Remember, you're going to let x be 0, solve for y, and let y be 0, and solve for x. If x is 0, does that thing go away right there, that negative 4x, or whatever it was, 4x maybe? So that would be the equation then you're left with right there, correct? What would y be then? Do I need to divide by negative 2?
Yeah, negative 11.
So 8 divided by negative 2 would be? Negative 4, right? Okay. So now, that gives me that first point. Now I'm going to look at doing the same thing, but this is going to go, when this y is 0, that goes away, right? So now what do you get for x when you solve that for x? Careful. Negative 2. Okay. So now we'll plot those, right? 0, negative 4. Right there. And negative 2, 0 right there, right? What kind of line am I going to use? Okay. All lines are straight. Solid. So create that line. So then I went up 4 over 2, another point there. So I get that, right?
I did it right. I did positive too.
Okay. So your line would be going the other direction, right? You'd have a positive slope. Yep. So now I need to decide, do I shade above or below? Okay. Well, what order pair makes most sense to substitute here? 0, 0. If I plug that number in to here, it gives me -4 times 0, which is 0, right? -2 times 0 is 0. So we get 0 plus 0. So 0 greater than 8. Is that true or false?
False.
That's false. Okay. So what happens here is that then if that's false, then everything on the same side of that point is also false. Does that make sense? So you're going to shade on the opposite side that this 0, 0 came from, which, if you're thinking graphically, is actually below that line there. Does that kind of make sense on how to do that? So a true statement, when you're using this substitution technique, you shade where that point came from. A false one means that those are not solutions. The solutions show up on the opposite side of the line. Okay? Does that make sense? Okay. Now, to guarantee that, to recognize that that is absolutely true, if I choose this point here, -4, -2. So I get -4 times x of -4 minus 2 times my y of -2. Is that greater than or equal to 8? Well, -4 times -4 is what? Times. -4 times -4. 16. So taking that point, plugging it into this stuff here, I get 16. This is going to give me +4. So it's 16 plus 4? 20. Is 20 greater than 8?
Yes.
Yes. And that's why we shaded over there where -4, -2 came from, right? Because everything over in that region is also going to give me a true statement. Is that all right? So I think that's substitution. I prefer that, okay? Now, you might be a person, like I said, that says, I don't like this. And you come up to this and you say, I'm going to rewrite this as -3y less than -2x plus 6. And then I've got to divide by -3, so I get y, be -2/3 x. This will be -2. Do you remember what you do when you divide an inequality by a negative?
No.
You remember switching the direction of it? So if I rewrite it in y equals mx plus b form, you can do it, but there's a lot of things at play there that you might get confused with. Okay? And actually, because that should be a positive 2/3 here. So I should put plus sign right there. But -2 be my y-intercept, up 2 to the right 3. Okay? Gives you that point there. So the same 2 points I plotted earlier. And now this says y is greater than, so because it's y first, that means shade on top. So you could do that, but when that number and ultimately that number, when your constant and your y coefficient are not multiples of one another, you're going to get nasty fractions for your y-intercept, which would be hard to graph. Okay, so this x-intercept, y-intercept technique is the best approach. So that brings us to these.
Yeah, these are.
Okay, and these are special cases they should be simple. We've heard me say this before. Sometimes when we simplify things, make things simple, we overthink them and they become hard. Okay, so this one says y is less than 3, right? Remember when graphing, we're first going to graph this. Y is 3. Remember seeing that previously? And remember what this is. This is a rule to create a bunch of ordered pairs. That's what all equations are. Rules to create ordered pairs. So if I give you some ordered pairs, this is saying your y value is 3. Does it say anything about your x's? No. So x can be anything. X could be -4, could be 1, could be 3, could be 0. Okay? But if I were to plot those points, -4, 3, 1, 3, 3, 3, where do all those points show up? Straight across. Horizontal line right here through what value? What number does it go through on the y-axis? 3. So when you see, so the shortcut that I taught you was that when it's y equals a number, it's a line through that axis, so the y-axis, at that number. So it has to be horizontal through 3, right? Now it's a dotted line because of the inequality symbol being just a less than. Now I need to shade, just think of this, these are easy than what we just did. If y is less than 3, am I going to shade above or below? Below. So that is the stuff that is below. That's y is less than 3. And think about this. No matter what point you choose on here, no matter what ordered pair those red points are the y values of all those red points, or any point in the yellow, are the y values of those ordered pairs all smaller than 3? Yeah.
Wait, hold up. So you choose, right?
Yes, if I chose any of these points, so let's say I choose 0, 0. I chose 0, 0. The y value for 0, 0 is 0. Is 0 less than 3? Yes, and that's why that point was in the yellow. Okay, so we're shading all this stuff down here. Okay, do the next one on your own. You graph that line. And y equals -2. And now it says greater, so it's greater than or equal to, so it's a solid line, right? And now where am I going to shade? Above that or below that? Above it, because it says y is greater than, so we're going above. So we're shading all this stuff up here. Okay, so if I picked out a number, picked out an ordered pair on here, just to verify, that ordered pair is 0, 0, right? I plug in the y value of 0 is 0 greater than -2. That's true, right? And that's why we shaded up there. All those y, at any point you choose in the green, the y value is going to be bigger than -2. Okay? So if that was all my equations with y in them, when just y, let's do some with just x. It's really the same approach, okay, but the y is a horizontal line, right? So x is, remember, is a vertical line, and it's going to be a vertical line through 4 now. So vertical line through 4 now, do I use a solid or dotted line? Solid. Okay, now when we draw vertical lines, we don't have a top and bottom, right? We have a left and right. And the idea is x's, now you're going to focus on your x-axis. What numbers, when we see x is less than or equal to 4, which side of that line would be the numbers less than or equal to 4?
2.
Okay, so things to this side, right? So if I shade all of this, would those all be points in which you choose any ordered pair? So let's choose that ordered pair right there. -4, 3. Is that x value of -4 less than or equal to +4? Yeah. Anything in the green is going to have an x value that is less than or equal to, excuse me, or equal to 4. Cool with that? Okay. The next one says x is greater than -5. So what kind of line? Dotted line, and it's going through -5. So now when we say greater than, we're saying what numbers are bigger than -5, right? What x value? So be all the things on this side. Because choose one of those points. Choose 0, 0. is 0 greater than -5 if I chose 0, 0?
Yeah.
Yeah. So I got to shade where I get true statements from.
Oh.
Is that all right?
Yeah, I was
Is this something we can do?
I like this.
Okay. So my hopes are that when we do substitution, we choose convenient points to make our decision, right? If I were to give you something like this, okay? Actually, not that one.
So we do have one, right?
Yeah.
How we get in the
Round 20.
whether he
So if I ask you to do this, let's see here, and I say shade so this is like y, let's go less than or equal to, this is -7x, that's the equation there. Okay, and I ask you to use the substitution technique to do this. Is 0, 0 available to me?
Yes, it is. Wait.
Why is it not, Lindsay? Because it's on the line, okay? So because it's on the line, that's not going to tell you whether you get to shade on that side of the line, either side of the line. Does that make sense? If you choose, because we're looking forward to shading either on one side of the line or the opposite side. Well, if I choose a point that is on the line, the result from that doesn't indicate which side of the line to choose from or the shade from. So what I would do in this case is I would stay I'm going to highlight 8 points that I could maybe choose. That's a good one to choose because the multiplicative properties of 1 are about as easy to work with as the multiplicative properties of 0, right? So if I tried 1, 1 here, put 1 in there, is that less than or equal to -7 times 1? I can do that multiplication pretty quick, right? Is 1, that's a 1. My 7s and 1s kind of look the same. Is 1 less than or equal to -7?
Yeah.
1 is greater than, right? So this is false. So do I shade where that point came from? If it's false, I shade on the other side. I'm going to shade over there. Does that kind of make sense? Okay. Now, other numbers that I like to choose, maybe 1, 0 would have been better. Because now, this would be 0, and this would be 1, so now I get 0 is less than -7. Maybe an easier thing to think about. Is 0 less than -7? No. Or, what about this? Let's make x. And these are all things you can think about as you're kind of doing your problem. The hard part about this question is evaluating arithmetically at this 7x. So let's see if I can choose x to be a 0. If I choose this point right here, x is 0, y is 1, I put 1 in for y, put 0 in for x, it gives me that, right? Is 1 less than or equal to 0?
No, it's greater than.
All right, so that's false. So then shade on the opposite side. So again, from that, we would shade on that side. Does that make sense? So if I can, I'm going to try, when I substitute, choose an ordered pair that has at least 1 0 in it. Okay? And if 0, 0 is not available to you, there will be an ordered pair that has maybe 1 0 or 0, 1 that would be available. Okay? We'll give you, so like the math Excel's over, you got about 10 minutes, 11 minutes here to work on that. I'd like you to be working on that. About 20, 21 questions, I think. It's going to be due on Wednesday. You get a little bit more time than a normal assignment. There's a little bit more graphing in this. The plan for the next couple days, guys, is we are going to keep working with this, but we're going to essentially, the next section is to take those two equations right there that we worked on and put them on top of one another. And when we put them on top of one another, the shading should overlap, and we should come up with an intersection of shaded regions. Does that make sense? You remember taking two lines and see where they intersect? Find the one point of intersection for two lines. we're going to take two inequalities, intersect them, and see what overlapping points are being shared. Okay? So the next section is doing exactly what you're doing here, but it's basically two problems inside the same graph. Okay? So we'll continue to work on this. The plan for this week is at the earliest, we'll have a test on Thursday. At the latest, it'll be Friday. Okay? So plan for it to be Thursday. The closer we get to that, I'll let you know what else is going to be Thursday or Friday. It's not open yet?